All right, so now we're into Venn diagrams and set operations. So our first thing is called a universal set, and it's labeled as capital U, and it's a set of all elements under consideration. And without having an actual box, what this box is going to be it's basically going to be listed something like that. And if you can see over here, that's what it is. But this one has a subset within it. So that's why, we don't have that. But this is going to be all elements under consideration, anything in that box. Now, sets within U are labeled and enclosed in a circle. So set A is within U. So if we call this the set A, we're highlighting it, and whatever's in set A, that's within our universal set. So that's going to be what the shaded region is. Now we can do a couple operations. We can do union. So the union of sets A and B is going to be denoted A union B, and it's a set of elements formed by combining all the elements of A and all the elements of B into one set. And we usually call this OR. So it's in either A or it's in B. Okay. And another way to define it is A union B is equal to the set of X such that X is the element of A or X is the element of B. So that's why we use the OR here. Okay. Now, what does it look like with this? Again, remember that whole thing is universal. So A is here, B is here, and it includes everything in both of them. So it has to be either in here or the intersection here or over here. So it's going to be all of that. So it's going to be the or. So it includes everything. Okay. Now we have the intersection. I mentioned that a little bit quickly in the last one. Now the intersection of sets A and B are denoted by A, then it's kind of the upside down U B. Now this is a set of elements in A that are also in B, and we call this one AND. Okay, so A intersect B is a set of X's such that X is the element of A and X is the element of B. And so where does that happen? Only in this intersection part right here. And hence, only the part here in yellow is where the intersection is. Now we also have disjoint sets. Now, if A intersect B is the empty set, then sets A and B are said to be disjoint. And so there's no intersection. And so because there's no intersection, there's also no crossover. So it's not going to have any elements at the same. And so it's called the empty set. They're disjoint. Okay, so that's going to be how we're going to denote that one. Here we've got the complement. Now, the complement of A, relative to a universal set of U, is denoted by A with this kind of a inch sign or a asterisk, and it's a set of elements of U that are not in A. So A complement is equal to X is an element of U, such that X is not an element of A. So if A originally contains everything in the circle A, then the complement is everything outside of that. So that's kind of how we're going to look at that. So A is in here, and the complement of A is everything out there. So it includes the stuff in B and everything else in the universal set. So that's how the complement works. All right, so now let's look at some examples here. We have R, S, and T, and U. Okay, so we're going to find R union S. So with a union for A, it's going to be, we're going to have what? We're going to have what's going to be in there. There's going to be 1, 2, 3, 4 for sure. 1, 2, 3, 4 because it's union, so it's or. So it's going to be in this or it's going to be an S. So we have 1, we've got that already. 3, got that already. 5, we don't have that one yet. And 7. So that's going to be the union. So everything that's in this one or this one. Okay. What about this one? That's intersection. So B, where does R and S intersect? Well, that means where are they the same? Well, it's the same here at 1 and 1. And here we have a 3 and a 3. And so the intersection is going to be 1 comma 3. All right. What about C? C is S intersect T. All right. So that one is going to be what? Well, here's S and here's T. Well, if we look, that's 1, 3, 5, 7. Those are all odds. This is evens, 2 and 4. So there is nothing that intersects. And so this is just going to be the empty set. And D asks for S prime or the complement of S. So our universal is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's everything that's not in there. So S complement is going to be everything that's not an S. So it's not going to be 1, but it'll be a 2. It's not going to be 3, but it'll be a 4. Not going to be 5, but it'll be a 6. Not going to be a 7, but it'll be an 8. And it also will be a 9. So we have 2, 4, 6, 8, and 9. That's not in S, but it's in our universal set. Okay. All right, so let's stop there and we'll come back for some more.